So after learning how to graph rational function by hand, here we can begin to talk a little bit about our our rational inequality. So rational inequality is very similar to polynomial inequality that we discussed in previous videos. So very similar steps with a couple of things added in. So just like with the polynomial inequality, you got to find the x-intercept or your critical points. And then you got to here you got to find the vertical asymptotes because vertical asymptote divides my graph into different parts. Okay, as you see from the graphing of rational function. Then we're gonna graph the function in the graphing calculator. So now we will know how to look at the graph that we actually put it in the calculator. Okay, after learning how to do things by hand, calculator become much easier to use. Then we're going to state the solution using our interval notation. So you will notice a lot of similar steps, okay, as what you've done before. So consider this rational inequality. So my function is already by itself greater than or equal to 0. So what we're going to do first is to find your x-intercepts, and then we can find the vertical asymptote. So when we graph it, then we know where our asymptotes are located. So find the x-intercept, very similar steps as I showed you in the previous video. So I'm gonna set my function equal to 0, means over 1. So I can quickly use a cross product to help me. So 0 times these 3 terms down here is still 0. 1 times those 2 terms up there is still 4x plus 2. So to get x by itself, move the positive 2 over, divide both sides by 4. So my x is equal to -2. So that means my x-intercepts is going to be, not -2, -0.5. So my x-intercept is going to be at -0.5, comma 0. Number 2, find the vertical asymptotes. So let me go ahead and factor the top, which I can factor out a 2. That will give me 2x plus 1 over the trinomial down here, 1 and 5, positive 5 in the outer, -1 in the inner, to give me positive 4, which I'm still greater than or equal to 0. So nothing can be canceled out top and bottom. So my denominator, set them equal to 0. Therefore, my 2 vertical asymptotes are going to be x equal to 1 and x equal to -5. Now let's graph it, and I'm gonna take a picture of that of what we graphed, so I can begin to draw some of these. Oh, sorry. Okay. Parenthesis 4x plus 2 divided by x squared plus 4x minus 5. All right, so let's graph it. Oh, sorry, let me change my window back. Just for the curiosity. Degree of the numerator is less than the degree of denominator, so the horizontal asymptote is going to be the x-axis. So this is very similar. This is exactly the same question as I done in the previous video. So all I need here, let me take a picture of this thing. Then I can kind of sketch in my my points. Oh, give a minute. Moving too fast. Come on, don't freeze on me. Here we go. All right, number 3 is graphing it. Okay, and sketch on the paper. So I will need you to kind of sketch it like I'm doing. So it'll make sense what you're trying to draw. So the points, okay, the points, x-intercept, you got to indicate your x-intercept. All right. If it helps, write it down, negative half. Your vertical asymptotes. Let me use a little bit thinner. X. 1. That's right here. Let me do red. X equal negative 5. 1, 2, 3, 4, 5. This part right here. And I'm going to purposely label them as well. X equal to negative 5 and x equal to positive 1. Okay. All right. Number 3, number 4, highlight the parts of the graph according to the inequality. So once my function is by itself, okay, then I can see my function. What I need to look at is greater than equal to 0. So greater than equal to 0 means we will look what is on the x-axis and above it. Okay. So since we said that the horizontal asymptote is the x-axis, and the only point that the function cross over the x-axis is at the x-intercept negative half 0. So that means as x going to the right, okay, as x going to the right, it will not cross over the x-axis again on this side. So that means this part of the graph is also staying above it. This part of the graph is above it. Okay. This part to the left of the negative 5 vertical asymptote, this side got to be below the x-axis because I only cross over at negative half comma 0. So that means this portion of it stay right below your x-axis or horizontal asymptote. So that was 3 and 4. Now, once I highlight it, now I can see the parts that is above the x-axis. So it's going to be from the vertical asymptote. It's very important. Your solution from negative 5 using parentheses because it's a vertical asymptote. That's why we got to use parentheses, comma, all the way to negative half. From this negative 5 to negative half, this part of the graph is above it. So I'm going to say to negative half, and I'm going to use bracket for my negative half because the greater than or equal to parts. So that means I need to look what's on the x-axis and above. So this is the part where it says greater than equal to. So with the equal to, I got to use brackets. Union, where else my graph is above the x-axis. All right, it's going to be from the vertical asymptote 1, keep on going to the right. There you go. That's my answer. All right, let's try another one. All right, so this one I got 2 terms, okay? The other side is not equal to 0. So while I'm finding the x-intercept, I'm going to move that positive 2 over to the other side. So I get x plus 1 over x plus 3 minus 2 less than 0. So I think I mentioned this during the review. Whenever we are combining a fraction with a whole number, we can always use a little trick. The ancient Chinese secrets. The trick is basically working out the problem just like converting mixed number into improper fraction. I can take my denominator times my whole number and then take the x minus 1 minus what's up here. So x plus 3 times 2 is 2 times x plus 3. And need to get subtracted by what's on the numerator already, x plus 1. Whole thing still over, LCD, x plus 3. All right, now I'm just going to distribute the top. So that will give me x plus 1 minus 2x minus 6, whole thing over x plus 3, less than 0. So once I simplify this, this is going to be negative x minus 5 over x plus 3, less than 0. Now I can use my cross product. 0 times those is gone. So that would just be negative x minus 5 equal to 0. So x is equal to negative 5. Move the negative x over, x equal to negative 5. So my x-intercept is at negative 5, 0. All right, so we got to simplify the simplify the rational expression part, or my rational function. Got to simplify it in order to help me to find the x-intercept. And it's very important that once we simplify it at this point, right before this part that I used to do the cross product, this is basically the simplest form. Okay, this is the simplest form because this place right here, this step right here, does actually help me to find the vertical asymptote. Because in order to find the vertical asymptote, I have to be able to factor the numerator and denominator, but the function or the fraction I'm factoring is actually one term. I don't know if you've ever noticed that. Every one of the vertical asymptote type of problem we did is only one term, one rational function term. Okay, that's the reason why I have to when this problem had two terms, I have to make them into one term. Okay, so since my numerator and denominator is, I can't really factor anything, so anything can cancel top and bottom. Then I can just go ahead and set my denominator equal to 0. My vertical asymptote is going to be x equal to negative 3. All right, now let's do the graphing part. So what do I graph? Well, let's graph right here. Not the original problem, but after I move that term back over after I move the 2 to the left side. That's the part I need to graph, because I don't want to graph the expression that I simplified just in case if I lose some characteristics. So this is two terms. So my first term started with a parenthesis. My numerator started with a parenthesis, x plus 1, close parenthesis, divided by x plus 3, put in a parenthesis, close a parenthesis for x plus 3, and close a parenthesis for my first term, minus 2. Excuse me. As you can see, the degree of the numerator and denominator here are the same. So the leading coefficient is your horizontal asymptote, which is negative 1. And that's what's kind of showing here. Can't really see it, but there's actually a horizontal asymptote right here, negative 1. All right. So the x-intercept, which was at x equal to negative 5, which is right here, vertical asymptote is at x equal to negative 3, which is right here. All right. So that's 3. And number 4, highlighting. All right. What am I looking for? Less than 0. So I'm looking for what's below the x-axis, not including what's on the x-axis, okay? No equal to, I'm using parentheses. What's below it, so this part is below. So that's coming from negative infinity all the way to my negative 5, my x-intercept, and picking up the part that's below on the right side of my vertical asymptote, which is x equal to negative 3. Let me write it down. So my solution got to be from negative infinity all the way to negative 5 using parentheses. All right. So I'm using parentheses for negative 5 is because this is less than 0. There's no equal to. Union from negative 3, keep on going to the right. And the reason why I'm using parenthesis for my negative 3 is because that's a vertical asymptote. There you go. That's my answer. Okay. So the highlighted part, okay, is the same as my solution. All right, let's try one. Let's try this one. This one is a little bit trickier. All right, let me move this term over real quick. And then I can begin to simplify them, okay? All right, so find x-intercept. This is 6 over. I'm going to go ahead and factor this. Because when I'm combining two fractions, I got to find the LCD. That's going to be plus 2, plus 2. All right, negative 2 over x minus 4 come over, become positive 2 over x plus 2, x minus 2. So my LCD, all right, the plus 2 repeated one time. Let me put it right here. I got plus 2, and I got plus 2 and x minus 2. So my LCD got to be the plus 2 repeated, counted one time. The other plus 2 did not repeat, counted one time. X minus 2 did not repeat, counted one time. All right, so this is my LCD, quite big. That's going to be less than or equal to 0. Okay. Plus 2, and then minus 2. All right, let's see. Let's try this, okay? All right, what does LCD have that my first denominator do not have? My first denominator do not have x minus 2, so we take that x minus 2 times my numerator. Okay, this is the same thing as we talk about during the review. Plus 2 times. What does my LCD has that the second denominator do not have? My second denominator is missing the extra x plus 2. So we take that times my numerator. So that's how we find the equivalent fraction. So now I'm just going to simplify my numerator, which is going to be, you can do this on the side. I can do this real quick. 6x plus 2x is ax. Negative 12 plus 4 is negative 8. Okay. Negative 12 plus 4 is negative 8. So if I factor this out, it's only going to be 8 times x minus 1, which is nothing to cancel with down here. So this is my factor form. Can come in handy when I find the vertical asymptote. All right, so to find the x-intercepts, let's do another cross product. 0 times these three factors is 0. Set it equal to 1 times ax minus 8. So my ax is equal to 8, x equal to 1. All right, so I should have an x-intercept at 1, 0. Vertical asymptote. So since there's nothing to factor, well, this is kind of weird. 1 x-intercept, but my graph is going to be having 3 asymptote. Well, 2 asymptote because the 2 plus 2 are the same. All right, so the already factored after I simplified it before I do my cross product. This is the one. It's in the simplest form, and that's the one I'm going to. That's the one I'm going to set my denominator equal to 0. So my 2 vertical asymptote is at negative 2 and positive 2. All right, so let's graph and highlight. So let's go back up here. This is the function or expression I'm going to put it in the graphing calculator. All right, 2 terms. So first term started with a parenthesis. 6 divided by open parenthesis for the, you know what? This is already factored. Let me go ahead and type in the original denominator, okay? So I can put those 3 terms as 1 parenthesis. So that will be x squared plus 4x plus 4 close parenthesis for my denominator, and close parenthesis for my first term, plus open parenthesis for the second term, 2 divided by simply just x squared minus 4. All right. So I'm just, I factored it here because once I move it over, then I will find the LCD. So I kind of skip over, rewrite this expression once it move over. I went ahead, moved it, and factored it. But when I key in the calculator, it's just easier to type in x squared minus 4, type in the actual LCD rather than in factor form. All right. Oh, interesting little problem. Interesting little picture. By the way, x times x times x down here is actually x to the third. So the degree of the numerator is less than the degree of the denominator. So again, the x-axis or y equal to 0 is going to be the horizontal asymptote. So my function does cross over the horizontal asymptote over the x-axis at x equal to 1 right here. That's what it shows right here. So we were doing it right. Okay. So if that's the only point, okay, that's x equal to 1. All right. 2. Let me try to, oh Lord, a little bit crooked, but it's okay. That's x at, that's the asymptote x equal to 2. This is vertical asymptote x equal to negative 2. All right. So I'm looking for the function that is less than equal to 0. Negative 12. Yeah. Less than equal to 0. So that's below the x-axis. Hold on a minute. Did I do this right? Go to my table. Yeah, 1, 0. Okay. So I was right. 1, 0. So only this part right here is actually below the x-axis. All right. Gotta be very careful when the x-intercept and the asymptote are so tight together. Make sure that your x-intercept is correct. Otherwise, you're gonna have a hard time seeing it. All right. So this is from 1 to 2. So since I have an equal to, since I do have an equal to, then my solution is going to be starting at 1, right? Only below the x-axis. This is the only part below the x-axis. To the left and to the right of my two vertical asymptote, it actually never cross over. So that means as an x going to the right and the left, the graph is actually hovered right above the x-axis. Never crossed it, only crossed it right here at 1. So it's going to be from 1 to 2. Parenthesis on the 2 because that's a vertical asymptote. Bracket on the 1 because my inequality has an equal to. All right. So just quickly kind of talk a little bit about rational inequalities after we learn how to draw rational function by hand. That will conclude this video. Thank you for watching.